Deep in the vast ocean of space, where darkness stretches beyond comprehension, lies a place so packed with cosmic strangeness that even the most brilliant minds can only scratch the surface of its secrets. The Hercules Cluster, a sprawling family of galaxies over 500 million light-years away, isn't just another dot in the night sky. It's a treasure chest of mysteries waiting to be unlocked. Imagine a region so dense with celestial bodies that light itself seems to bend under their collective gravity, where entire galaxies dance in formations we can't fully explain, and where signals echo across the void, hinting at phenomena that defy the very laws of physics as we know them. What if I told you some of these enigmas aren't just academic curiosities, they're cosmic puzzles so baffling they could rewrite our understanding of the universe? From ghostly radio emissions with no apparent source to galaxies that move in ways they absolutely shouldn't, the Hercules Cluster is brimming with stories that sound like they're ripped straight from science fiction. Yet here they are, documented by telescopes and studied by astronomers, leaving us with more questions than answers. This isn't just about distant specks of light, it's about the thrill of discovery, the humbling reminder that for all our advancements, the universe still holds cards it hasn't shown us. And today, we're pulling back the curtain on 25 of the most astonishing, spine-tingling phenomena lurking in this cluster. Some might challenge what you think you know about space. Others might leave you staring at the night sky, wondering what else is out there, hiding in plain sight. So buckle up, because we're about to take a journey into the unknown, where every revelation is stranger than the last. Right in the heart of the Hercules Cluster, where thousands of galaxies jostle for space, astronomers stumbled upon something that shouldn't exist, a vast, haunting emptiness stretching over hundreds of millions of light-years. They call it the Hercules Void, and it's not just any empty patch of space. This colossal nothingness is so enormous it could swallow entire galactic superclusters without a trace, leaving scientists scrambling for answers. How could a region so densely packed with galaxies suddenly give way to nothing? Some think it's a cosmic accident, a rare but possible gap in the universe's structure, like a missing puzzle piece in an otherwise complete picture. Others argue it's something far more unsettling, a fingerprint of dark energy, that mysterious force pushing the universe apart. If true, the void might be a window into forces we can't yet see, warping space itself on scales beyond imagination. But here's the real shocker. According to our best models of how galaxies form and cluster together, voids this size shouldn't even be possible. It's as if the universe rolled a pair of dice and got a number that doesn't exist. What makes the Hercules Void even stranger is how eerily quiet it is. Most cosmic voids still contain a smattering of galaxies, but this one is almost clinically empty. Even the faint whispers of background radiation seem to fade as they cross its boundary, as if something is actively silencing the cosmos. Could it be evidence of an entirely new kind of physics? Or just a once-in-a-universe quirk that defies explanation? Whatever the answer, this gaping cosmic blank spot forces us to rethink everything we thought we knew about how the universe organizes itself. And that's just the first mystery lurking in the Hercules Cluster. But the Hercules Void isn't the only enigma keeping astronomers up at night. Just a cosmic stone's throw away, there's a quasar behaving in ways that defy logic, flaring and dimming like a malfunctioning cosmic light bulb. Dubbed the Flickering Quasar, this blazing beacon, powered by a supermassive black hole, should shine with near-constant brilliance. Instead, it flickers unpredictably, sometimes vanishing from view entirely before roaring back to life weeks or months later. What could possibly cause such wild swings in brightness? One leading theory points to the black hole's feeding habits. Normally, as matter spirals into a black hole, it heats up and glows steadily. But if the flow of gas and dust becomes erratic, like a starving beast gorging itself one moment and fasting the next, the light output would spike and plummet in response. Yet even this explanation falls short when faced with the quasar's extreme behavior. Some fluctuations happen too fast, as if something far stranger is at work. Then there's the cosmic dust theory. Imagine a thick, drifting veil of debris passing between us and the quasar, temporarily obscuring its light. The problem: dust clouds don't move quickly enough to explain the rapid flickering. Unless, of course, we're seeing something entirely new, perhaps structures within the quasar itself, like massive rings of debris or warped space-time bending light in ways we've never witnessed before. The most unsettling possibility, a cosmic collision. Some researchers suggest another supermassive black hole might be orbiting nearby, its gravity yanking on the quasar's accretion disk, stirring up violent turbulence. If true, we could be watching two monsters locked in a gravitational dance, their interactions warping reality itself. Whatever the cause, this flickering titan forces us to question everything we thought we knew about how quasars and black holes behave. And the scariest part, it's not the only one acting this way. Floating silently through the Hercules Cluster like echoes from a forgotten cosmic event, astronomers have detected something that shouldn't be visible at all: enormous, ghostly loops of radio waves stretching hundreds of thousands of light-years across. These faint, shimmering structures, invisible to optical telescopes, appear like celestial fingerprints etched into the fabric of space itself. What's baffling isn't just their size, but the fact that they seem to have no clear source. No active galaxies, no energetic black holes, no exploding stars, just these eerie, glowing rings hanging in the void, as if the universe itself decided to leave behind a message. One leading theory suggests these loops could be the aftermath of a cataclysmic crash between galaxies that happened billions of years ago. When two galaxies collide, their supermassive black holes often merge, releasing unimaginable amounts of energy. That energy might have sent shockwaves rippling through intergalactic gas, leaving behind these faint radio imprints like scars. But here's the twist: the loops don't match the expected patterns of a typical merger. They're too symmetrical, too perfectly shaped, as if something far more precise than chaos created them. Then there's the dark matter angle. Some researchers speculate these loops could be traces of dark matter, the invisible glue holding galaxies together, interacting with itself in ways we've never observed. If true, this would be our first real glimpse into the hidden physics of dark matter, a substance that makes up most of the universe's mass but remains utterly mysterious. Imagine dark matter particles colliding and annihilating in vast, unseen halos around galaxies, releasing bursts of radio waves as they fade into nothingness. Yet the most unsettling possibility is that these loops aren't remnants at all, but something still active: cosmic structures we don't yet have the language to describe. Could they be the remnants of a long-dead civilization's technology, or the signature of an unknown natural phenomenon? Whatever the answer, these ghostly loops remind us that the universe is still playing a game of hide and seek, revealing just enough to keep us questioning everything we think we know. Nestled within the swirling chaos of the Hercules Cluster, astronomers have found a celestial family portrait that makes no sense, a tightly packed group of stars that shouldn't exist together. This bizarre gathering, now called the Impossible Star Cluster, is like a cosmic daycare center where newborns, teenagers, and elderly stars are all crammed into the same room, defying every rule we know about how star clusters form. Normally, stars in a cluster are born from the same collapsing cloud of gas, making them siblings with nearly identical ages. But this group, it's a generational free-for-all, with some stars shining brightly in their youth while others nearby are ancient relics on the brink of fading out. So how did this stellar oddity come to be? One camp of astronomers argues it's not a true cluster at all, but the mangled remains of a dwarf galaxy that wandered too close to the Hercules Cluster's gravitational pull. Over billions of years, the larger cluster's tides could have ripped the Dwarf Galaxy apart, scattering its stars, some old, some young, into this tight, mixed-up knot we see today. It's like finding a pile of artifacts from different centuries all jumbled together in one spot, evidence of a violent cosmic robbery. But here's where things get even weirder. Other researchers point out that the star's chemistry doesn't quite match the Dwarf Galaxy theory. Instead, they propose something far more chaotic, a series of galactic smash-ups so violent they triggered multiple waves of star formation in the same location. Picture two galaxies colliding, their gas clouds compressing and igniting new stars, only for another galaxy to plow through later, repeating the process. The result, a fossil record of cosmic crashes, with each generation of stars preserving the timestamp of a different collision. Then there's the rogue possibility that we're seeing the aftermath of a runaway stellar nursery. Imagine a massive star forming regions so dense it birthed stars sporadically over eons, with some stars forming early while others ignited much later from leftover gas. It's as if the universe hit pause and play on star creation multiple times in the same spot, leaving behind a layered cake of stellar ages. Whatever the truth, this impossible cluster challenges our most basic assumptions about how stars live and die together. It's a reminder that the universe doesn't always follow the rules, and sometimes the most baffling exceptions are the ones that teach us the most. And just when you think the Hercules cluster can't get any stranger, wait until you hear about the galaxy that's spinning backwards. At the fringes of the Hercules cluster, where galaxies thin out and darkness takes hold, astronomers have uncovered something that shouldn't exist, a pocket of space where dark matter refuses to follow the rules. This cosmic rebel, known as the dark matter anomaly, behaves in ways that clash violently with our most sophisticated simulations, leaving scientists questioning whether we truly understand the universe's hidden scaffolding. Picture this: according to decades of research, dark matter should be spread smoothly through galaxy clusters like an invisible fog, densest at the center and gradually thinning toward the edges. But in this peculiar region, the opposite happens. Dark matter clumps erratically, forming dense knots in unexpected places while leaving vast areas eerily empty, as if someone took a cosmic paintbrush and smeared the universe's hidden blueprint in chaotic strokes. What makes this anomaly so baffling isn't just its defiance of predictions, it's the sheer scale of the mismatch. Supercomputer simulations, which accurately model dark matter's behavior everywhere else, utterly fail to reproduce this strange clustering. It's like watching a weather forecast predict sunshine, only to step outside into a thunderstorm. Some researchers suggest the answer lies in dark matter's own complexity, that it might not be a single, uniform substance, but a mix of different particles interacting in ways we haven't yet imagined. Others propose something even more radical, that dark matter isn't entirely dark. Small fractions could interact weakly with light or other forces, creating subtle tugs and disruptions that reshape its distribution. Imagine tossing a handful of iron filings into a magnetic field. Their movements would shift unpredictably, tracing hidden patterns invisible to the naked eye. If true, this anomaly might be our first clue that dark matter is far more dynamic than we ever suspected. Then there's the gravitational wildcard. Could unseen structures, cosmic filaments, or primordial black holes be warping dark matter's behavior from the shadows? Or is this a sign that gravity itself works differently on these colossal scales, bending the rules we've taken for granted? Whatever the explanation, one thing is clear: this anomaly isn't just a curiosity. It's a glaring crack in the foundation of modern astrophysics, a silent challenge to our understanding of the universe's most dominant yet elusive substance. And until we solve it, we're left staring into the dark, realizing just how much we still don't see. Deep in the chaos of the Hercules cluster, two cosmic titans are locked in a gravitational embrace so bizarre it defies everything we know about black holes. Meet the twin black hole paradox, a pair of supermassive monsters orbiting each other at a distance that should be impossible, closer than the width of our solar system. At this range, conventional physics says they should have spiraled into a cataclysmic merger eons ago. Yet here they are, circling like dancers trapped in an endless loop, challenging our understanding of how space-time behaves under extreme conditions. One of the biggest mysteries is the staggering time dilation at play. Because black holes warp space-time so severely, time for these two would pass infinitely slower than for the rest of the universe. From our distant vantage point, their orbital dance might appear frozen, as if the universe itself hit pause. But simulations suggest something even stranger, that their mutual gravitational pull could be creating a feedback loop, each black hole's distortion of space-time altering the other's path in ways that prevent collision. It's like two whirlpools spinning just close enough to share water but never merging, caught in a cosmic standoff. Then there's the gravitational wave enigma. When black holes merge, they send ripples through space-time signatures we've detected before. But these twins emit a bizarre, inconsistent hum of waves, flickering unpredictably instead of building toward a crescendo. Some researchers suggest their chaotic orbits might be kicking gravitational energy into higher dimensions, leaking waves into realms we can't observe. Others propose they're surrounded by a dense shroud of dark matter, muffling the expected signals like a celestial fog. The most tantalizing theory, they're not alone. A third, invisible black hole could be lurking nearby, its gravity subtly stabilizing their orbits like an unseen puppeteer. Or perhaps the extreme curvature of space-time near these giants has created a natural safety zone where the very fabric of reality prevents their collision. Whatever the truth, this paradox forces us to confront the uncomfortable possibility that black holes, the universe's ultimate destroyers, might also be capable of something we never expected: cosmic cooperation. And if that's true, the Hercules Cluster might be hiding even more rules waiting to be broken. Hidden among the Hercules Cluster's swirling galaxies, astronomers once catalogued a faint, unassuming dwarf galaxy until one day it simply wasn't there anymore. The disappearing Dwarf Galaxy, as it's now known, vanished from telescope observations like a ghost slipping through a cosmic crack, leaving behind only unanswered questions. At first, scientists assumed it was a technical glitch, a blip in the data, but repeated scans confirmed the impossible. An entire galaxy, home to millions of stars, had seemingly evaporated without a trace. The most unsettling part, when researchers combed through archival images, they found hints of the dwarf's presence, faint smudges of light where stars once huddled together. Yet in newer observations, those smudges had dissolved into the blackness of space, as if the galaxy had been erased. One theory suggests the Hercules Cluster's immense gravitational tides finally tore the dwarf apart, stretching its stars into thin, undetectable streams. It's like watching a sandcastle collapse under the tide, grain by grain, until nothing remains but the memory of its shape. But here's where the mystery deepens. If tidal forces were the culprit, we'd expect to see at least some remnants, debris fields of scattered stars or glowing trails of ionized gas. Instead, the area is eerily clean, almost sanitized. That's led to a spine-chilling alternative. What if the dwarf galaxy wasn't made of stars at all, but something far stranger? Some researchers propose it was a dark galaxy, composed almost entirely of dark matter, with only a handful of visible stars sprinkled like glitter on an invisible canvas. As those stars faded or died, the galaxy's true nature, a shadowy skeleton of dark matter, was laid bare, leaving nothing for our telescopes to capture. Then there's the rogue variable, interstellar dust. Could thick clouds of cosmic soot have drifted between us and the dwarf, smothering its light entirely? It's possible, but dust doesn't explain why the galaxy's gravitational signature, the way it subtly tugged on nearby objects, also seems to have weakened over time. Unless, of course, the dust isn't just hiding the galaxy but actively consuming it, a scenario that would rewrite our understanding of how dust behaves in space. The most tantalizing clue comes from gravitational lensing. Recent observations show faint distortions in the light of background galaxies, hints that something massive still lurks in the dwarf's last known location. If that's true, the galaxy might not have disappeared at all. Instead, its stars could have dimmed beyond detection, while its dark matter halo endured, a phantom limb of the cosmos we can only feel through its gravitational grip. Whether it's a case of cosmic demolition, a dark matter doppelganger, or something even weirder, this vanishing act forces us to confront an uncomfortable truth. The universe might be hiding entire galaxies in plain sight, not behind cloaks of invisibility, but simply because we don't yet know how to see them. And if one galaxy can disappear without warning, how many others have we already missed? Among the countless mysteries within the Hercules Cluster, one patch of sky stands out not for what it contains, but for what it lacks. Scientists call it the cosmic cold spot, a region where the faint afterglow of the Big Bang dips to temperatures colder than anywhere else in the observable universe. At first glance, it might seem like a minor statistical oddity, a cosmic quirk, but this chilling anomaly burns with questions that could reshape our understanding of reality itself. The cold spot spans nearly 200 million light-years, a staggering void where the cosmic microwave background, the universe's oldest light, registers significantly cooler than its surroundings. Mainstream cosmology suggests such variations should be rare and subtle, like gentle ripples on a pond. Instead, this spot is more like a sudden sinkhole, a deviation so extreme that standard models struggle to explain it. One leading theory points to a supervoid, an enormous, mostly empty region of space where the lack of matter causes light to lose energy as it traverses the void, creating a cold imprint. It's like walking into a refrigerated room. The environment itself saps warmth from anything passing through. But here's the catch: the required void would need to be so vast and so empty that it defies the expected distribution of matter in the universe. Simulations show structures this size shouldn't exist in our current cosmic timeline. That's led some researchers to propose a far wilder explanation: quantum entanglement on a cosmic scale. Imagine the fabric of space-time itself being woven with invisible threads, linking distant regions in ways that allow energy to drain from one area to another instantaneously, leaving behind this eerie cold patch. If true, it would mean the universe's quantum rules don't just apply to particles in a lab, but to the large-scale structure of reality. Then there's the multiverse angle. A handful of theorists argue the cold spot could be a bruise left by a collision with another universe in the distant past, a shadow of something beyond our cosmic horizon. It's a radical idea, but not without precedent. Certain models of inflationary cosmology predict such overlaps might leave detectable imprints, the most unsettling possibility. We're seeing evidence of physics beyond Einstein's relativity, where gravity or dark energy behave differently on scales we've yet to fully map. Whatever the explanation, this frigid anomaly isn't just a curiosity. It's a cosmic ice crystal forming on the window of our understanding, a sign that the universe still has secrets buried deep in its coldest corners. And as we peer closer, we might just find that the answers rewrite not just the story of the Hercules Cluster, but the very laws that govern existence. Amid the swirling chaos of the Hercules Cluster, a cosmic alarm clock has been going off at random intervals, an explosive burst of radio waves so powerful it outshines entire galaxies for milliseconds before vanishing again. But unlike typical fast radio bursts which flash once and disappear forever, this one keeps coming back. Known as the Hercules repeater, this enigmatic signal pulses with eerie consistency, defying our best attempts to explain its origin. Fast radio bursts usually fall into two categories: one-off cosmic fireworks or repeating signals with no discernible pattern. The Hercules repeater straddles the line between these extremes, firing off bursts with just enough regularity to intrigue scientists while maintaining enough unpredictability to keep them guessing. Some pulses arrive weeks apart, others cluster together in rapid succession before falling silent for months. It's like listening to a malfunctioning cosmic metronome, ticking at random intervals with no conductor to guide it. The leading explanation points to magnetars, super-dense, highly magnetic remnants of dead stars. When these neutron stars experience starquakes, their crusts crack under immense pressure, releasing bursts of energy that could explain the radio flashes. Yet the Hercules repeater's bursts don't quite match magnetar behavior. They're too frequent, too clean, as if something else is powering them. One theory suggests we're seeing interactions between a magnetar and an orbiting companion, perhaps a rogue planet or another stellar corpse, with their gravitational dance triggering periodic energy releases. Then there's the wild card, cosmic megastructures. While most scientists dismiss the idea, some have half-jokingly suggested advanced civilizations could be behind these bursts. Imagine a distant power grid switching on intermittently, or a beacon signaling across the void. The burst's unnatural regularity fuels these sci-fi speculations, even if evidence remains firmly in the realm of imagination. The real puzzle is the burst's energy signature. Unlike other repeating FRBs, the Hercules signals show a curious drift in frequency, as if the source is moving through a turbulent medium. Could this be a clue that the bursts are passing through dense clouds of interstellar plasma? Or is the source itself accelerating like a cosmic lighthouse spinning erratically? Until we solve this mystery, the Hercules repeater remains one of the cosmos' most tantalizing enigmas, a signal that refuses to stay silent, challenging us to decode its message. Whether it's a magnetar's cry, a cosmic collision, or something beyond our current understanding, one thing is certain: the universe loves keeping us on our toes. And just when you think you've figured it out, the next burst arrives, rewriting the rules all over again. Tucked away in the Hercules Cluster, a galaxy spins with a secret, an extra arm that shouldn't be there. Astronomers call it the Phantom Spiral Arm, a ghostly appendage stretching far beyond the galaxy's other graceful swirls. Unlike normal spiral arms, which curve in sync with the galaxy's rotation, this one juts out at an awkward angle, like a broken branch on an otherwise perfect tree. At first glance, it might seem like a trick of perspective, a chance alignment of distant stars. But the deeper astronomers look, the more this cosmic outlier defies easy explanation. One theory suggests it's the aftermath of a galactic near miss, a close encounter with another galaxy that tore a stream of stars loose, leaving behind a luminous scar. Gravitational tides can stretch galaxies like taffy, pulling debris into long, trailing arcs. If that's the case, this phantom arm could be a temporary wound, slowly fading as the ejected stars drift into the void. But there's a problem. The arm's stars are too orderly, too evenly spaced, lacking the chaotic sprawl of typical tidal debris. It's as if someone carefully painted this arm onto the galaxy, defying the messy violence of cosmic collisions. Then there's the perspective puzzle. Could we be seeing two galaxies superimposed, their overlapping arms creating the illusion of a single malformed spiral? Modern telescopes have ruled out most of these chance alignments, yet the arm's faint glow still matches the host galaxy's chemistry too closely for a simple case of mistaken identity. The stars in this phantom limb share the same age and composition as their spiral siblings, as if they were born together, just somehow flung out of sync. The most tantalizing possibility, a galactic memory. Some simulations suggest spiral arms aren't fixed structures but dynamic waves, rippling through a galaxy's disk like sound waves through air. Occasionally, these density waves can leave behind faint echoes, older arms that linger long after the wave has moved on. If true, the phantom arm might be a fossilized snapshot of the galaxy's past, a ghost of its younger, more turbulent self. Yet even this elegant explanation stumbles when faced with the arm's sheer persistence. Most transient features fade over millions of years, but this one clings stubbornly to the galaxy's edge, challenging our models of how spiral structures evolve. Whether it's a cosmic accident, a gravitational relic, or something entirely unforeseen, this phantom limb forces us to confront a humbling truth. Even the most familiar galaxies still hold surprises, whispering secrets we're only beginning to hear. And in the Hercules Cluster, where the rules of the cosmos seem to rewrite themselves daily, this enigmatic arm is just one more mystery waiting to unravel. In the swirling depths of the Hercules Cluster, a cosmic rebel streak cuts against the galactic grain, a massive hydrogen cloud hurtling in the exact wrong direction. Picture a salmon fighting its way upstream, except this salmon is light years wide and moving with enough force to make astrophysicists question their textbooks. This isn't just a gas cloud drifting lazily through space. It's a celestial misfit racing against the universe's traffic flow, challenging every expectation of how matter behaves in a galaxy's gravitational embrace. The enigma starts with sheer momentum. When galaxies rotate, their gas and stars follow a predictable choreography, swirling together like cream in coffee. But this rogue cloud, nicknamed the backstream bully, travels nearly perpendicular to its host galaxy's spin, as if it's actively resisting the pull of billions of stars. At first, scientists assumed it was a temporary hitchhiker, an intergalactic gas cloud passing through and briefly bucking the system. But observations revealed something far stranger. The cloud isn't just crossing the galaxy's path, it's embedded deep within the galactic disk, yet still defiantly moving against the current. One explanation points to magnetism on an unimaginable scale. Galactic magnetic fields, though invisible to conventional telescopes, can stretch across thousands of light years, channeling charged particles like cosmic rivers. If this cloud is ionized, bathed in enough radiation to carry an electric charge, it might be surfing magnetic field lines like a surfer riding a wave, propelled by forces we can't directly observe. The problem: most galactic magnetic fields aren't strong enough to redirect something this massive. Unless, of course, the Hercules Cluster hides magnetic anomalies far more powerful than anything we've seen before. Then there's the dark matter wildcard. Could an invisible knot of dark matter be lurking nearby, its gravity subtly tugging the cloud off course? Simulations suggest dense dark matter clumps could warp the trajectories of gas clouds, but never with this level of precision. It's like watching a marble roll uphill unless some unseen hand is guiding it. The motion seems impossible. The most electrifying theory: this cloud is the aftermath of a cosmic heist. Some researchers propose it was ripped from another galaxy during a close encounter, sent spinning in the wrong direction with enough velocity to escape its captor's grasp. Like a bullet ricocheting off steel, the cloud's backward motion could be the cosmic equivalent of a gravitational slingshot gone rogue. Yet even this explanation leaves gaps. The cloud's edges show none of the expected turbulence from such a violent origin. Instead, its boundaries are oddly crisp, as if something is actively shaping it, a force we haven't yet imagined. Whether it's magnetism, dark matter, or a gravitational fluke from the cluster's chaotic dance, this defiant wisp of hydrogen proves one thing: in the Hercules Cluster, even the simplest laws of physics are up for debate. And if a gas cloud can rewrite the rules, what else is hiding in plain sight, waiting to upend our understanding of the cosmos? In the heart of the Hercules Cluster, where galaxies jostle like commuters in a cosmic train station, astronomers have spotted an anomaly that shouldn't exist, a galaxy moving so fast it's practically tearing itself free from the fabric of the universe. Known as the redshift outlier, this renegade starlight shows a redshift measurement so extreme it defies both its location and our understanding of cosmic expansion. Redshift, the stretching of light waves as objects move away from us, typically increases with distance due to the universe's expansion. But this galaxy isn't just far away, it's fleeing at velocities that suggest either a colossal measurement error or a crack in cosmology itself. First, let's unpack the numbers. The redshift outlier's light is stretched nearly 20% more than neighboring galaxies at the same distance, as if it's being violently yanked backward by unseen forces. One explanation is simple human error, a glitch in spectral analysis or contamination from interstellar dust skewing the data. But after dozens of independent observations, the anomaly persists, gleaming like a rogue data point on an otherwise orderly graph. Then there's the runaway theory. Could this galaxy have been catapulted outward by some ancient cataclysm? Galactic collisions can fling stars, even entire star systems, into the void at incredible speeds. But for a galaxy this massive to achieve such velocity, it would need an energy source beyond anything we've witnessed, a gravitational slingshot involving multiple supermassive black holes or a dark matter avalanche we can't yet model. The most unsettling possibility, the redshift outlier isn't moving faster, it's sitting in a pocket of space where the rules of cosmic expansion differ. Most models assume the universe stretches uniformly like rising dough, but what if some regions expand faster than others, like bubbles in boiling water? This outlier could be a glimpse into uneven inflation, a flaw in the smooth cosmic tapestry we've taken for granted. As telescopes train their lenses on this cosmic fugitive, one thing is clear: whether it's a measurement quirk, a gravitational oddity, or a challenge to Einstein's legacy, this galaxy refuses to follow the script. And in a universe that's supposed to play by consistent rules, outliers like this don't just raise questions, they demand a rewrite. Deep in the gravitational whirlpool of the Hercules Cluster, two dead stars spin in a cosmic waltz that shouldn't be possible. A pair of neutron stars locked in orbit, one whirling like a frenzied top while its partner barely moves at all. Dubbed the mismatched duo, these ultra-dense stellar corpses defy every expectation of how binary neutron stars form, presenting a puzzle that starts with their very existence. Normally, such pairs arise from twin massive stars that lived, died, and collapsed together, their fates entwined from birth to supernova, but these two. Their spin rates differ by a factor of 1,000. One rotates hundreds of times per second, while the other trudges through a single revolution every few hours. The mystery begins with their violent backstory. Neutron stars are born from the explosive deaths of supergiant stars, their cores crushed into city-sized spheres so dense a teaspoon of their material would weigh 1 billion tons. When two stars this massive orbit each other, their deaths typically leave behind neutron stars with similar spins, like synchronized dancers. Yet here, the faster star spins so rapidly it's on the verge of tearing itself apart, while its sluggish companion behaves more like a fossil, an ancient relic frozen in time. So how did this odd couple form? One theory suggests the faster star wasn't part of the original pair at all, that it was captured by the slower neutron star long after their births, a cosmic hitchhiker pulled into orbit during a chance encounter. But the odds of such a precise gravitational capture in the crowded Hercules cluster are astronomically low. Another idea points to a bizarre stellar ménage trois. Perhaps a third star once existed in this system, its gravitational nudges transferring energy to one neutron star while breaking the other before being flung into the void. Then there's the kilonova wildcard. When neutron stars collide, they unleash unimaginable energy, explosions called kilonovas that forge gold, platinum, and other heavy elements. The mismatched duo's unstable orbit means they're spiraling toward each other, destined to merge in a cataclysm that could light up the cluster. But here's the catch: their uneven spins should have destabilized their dance long ago, triggering an early collision. The fact they haven't merged yet hints at an unseen force, perhaps a disk of debris or a magnetic field strong enough to act as a cosmic shock absorber, keeping them in check. The most startling possibility: the slower star isn't a neutron star at all, but a strange hybrid object, a neutron star with a quark matter core, or even a primordial black hole hiding in plain sight. Such an exotic partner could explain the system's gravitational quirks while accounting for the wild spin mismatch. Whatever the truth, this binary enigma forces us to rewrite the story of how stellar remnants live and die together. In a universe where symmetry is often the rule, the Hercules Cluster serves up another delicious exception, proving that even the dead can dance to their own rhythm. Deep in the Hercules Cluster, astronomers witnessed one of the universe's most violent events, except they never actually saw it. Meet the invisible supernova, a stellar explosion detected not by the blinding flash of light we'd expect, but by a ghostly whisper of neutrinos, the elusive, nearly massless particles that slip through matter like shadows through a wall. This cosmic detective story begins with sensors buried deep underground, where scientists caught a fleeting burst of these mysterious particles, tracing their origin to a patch of sky within the cluster. But when telescopes swung into action, they found nothing, no brilliant flare, no expanding shockwave, just an eerie absence where a dying star's final act should have been. So how does a supernova, a cataclysm so bright it can outshine entire galaxies, vanish without a trace? One leading theory points to cosmic dust on an unimaginable scale. Picture thick clouds of interstellar soot, dense enough to swallow light whole, wrapping the explosion in a shroud so opaque not even the most powerful telescopes could pierce it. It's like hearing fireworks behind a mountain. You know something spectacular happened, but the view is utterly blocked. Yet even this explanation strains credibility. For dust to obscure a supernova this completely, it would need to be packed tighter than anything we've observed before, a celestial curtain woven from material that shouldn't exist in such quantities. Then there's the failed supernova hypothesis, a star that teetered on the edge of destruction but collapsed inward instead of exploding outward. Some massive stars, rather than going out with a bang, may implode directly into black holes, their outer layers falling silently into the abyss without the usual fireworks. In this scenario, the neutrinos would be the only scream the star could muster as it vanished from reality, leaving behind no remnant, no debris, just an unsettling quiet where a giant once burned. But the plot thickens. A handful of researchers propose something even stranger, that we're seeing the aftermath of a collision between compact objects like neutron stars or black holes hidden within a cocoon of dense gas. These mergers can produce neutrino bursts similar to supernova, but their light might be trapped by the swirling maelstrom of matter around them, leaving only gravitational ripples and ghostly particles as evidence. The most haunting possibility, this wasn't just any star. It could have been a rare, ultra-massive progenitor, so large its core collapse defied all known models, creating a black hole so voracious it consumed the explosion before light could escape. Imagine a cosmic vacuum cleaner, swallowing its own detonation mid-blast, a supernova strangled in its cradle. Whatever the truth, the invisible supernova forces us to confront a humbling reality. The universe's most dramatic events might be playing out right in front of us, hidden in plain sight. And if stars can die without leaving a trace, how many other cosmic secrets are slipping through our fingers, detectable only by the faintest whispers in the dark? In the chaotic orbit of a pulsar within the Hercules Cluster, astronomers have stumbled upon a celestial paradox, a world that glimmers with possibility, quite literally. This candidate planet, unofficially dubbed the Diamond World, shouldn't exist where it does, spinning around a dead star whose gravitational fury should have torn it apart eons ago. Yet here it sits, teasing us with spectral signatures that suggest a surface or perhaps an entire core, crystallized into something resembling diamond. The story starts with an anomaly in the pulsar's radio pulses. These ultra-dense, spinning corpses of stars are cosmic lighthouses, their beams sweeping space with metronomic precision. But this one's rhythm hiccuped slightly, a telltale wobble hinting at an orbiting companion. When researchers trained their instruments on the culprit, they found not another star or a gas giant, but a small, dense object reflecting light in a way that made their instruments blink in disbelief. The readings screamed carbon, lots of it, packed under such extreme pressure that it might have formed a lattice of diamond-like crystal. But cosmic treasures are rarely so simple. One camp argues the data could be a cruel trick of perspective. Pulsars are notorious for warping spacetime around them, bending light in ways that might mimic the spectral fingerprints of carbon crystals. Even a chance alignment with a distant asteroid or debris cloud could scatter light in just the right way to fool our telescopes. Then there's the calibration gremlin. Some insist the instruments themselves might be to blame, their sensors misinterpreting mundane signals as something extraordinary. Others, though, point to the pulsar's violent history. When a massive star collapses into a neutron star, the explosion can blast away its outer layers, leaving behind a carbon-rich carcass. If this pulsar once had a carbon-heavy stellar sibling, the supernova's shockwave might have compressed its remnants into a diamond core, a glittering relic forged in stellar fire. Simulations show it's possible under the right conditions. Carbon could crystallize into a planet-sized gem, orbiting its dead creator like a cosmic keepsake. The most tantalizing twist, this might not be the universe's only diamond world. A handful of similar candidates have been spotted elsewhere, suggesting a bizarre new class of planets, ones born from the ashes of stars, their chemistry rewritten by violence. If confirmed, these worlds would redefine what we think planets are made of, proving yet again that the cosmos specializes in turning science fiction into fact. Yet until we peer closer, perhaps with next-generation telescopes or gravitational wave detectors, this glittering enigma remains just that, a maybe, a cosmic what-if spinning silently in the dark. And whether it's a diamond the size of a planet or the universe's most elaborate sleight of hand, one thing's certain: the Hercules Cluster has a flair for turning even the wildest fantasies into puzzles waiting to be solved. Stretching across the Hercules Cluster like a luminous artery, one of the universe's most enigmatic structures pulses with light, a filament of superheated gas so vast it could bridge galaxies end to end. But this isn't just another thread in the cosmic web. It's a radiant anomaly glowing far brighter than theoretical models predict. Under normal circumstances, these gaseous tendrils, part of the universe's hidden skeleton, are faint and diffuse, visible only through the subtle distortions they impose on background light. Yet here, the filament blazes like a neon sign in the void, betraying secrets about the forces that sculpt the cosmos on the grandest scales. What could possibly energize such a structure to this extreme? One explanation lies in the cluster's violent core. The Hercules Cluster is a cauldron of colliding galaxies, each harboring supermassive black holes that pump energy into their surroundings like cosmic engines. As these black holes devour matter, they spew jets of charged particles at near light speed, which could be heating the filament's gas to temperatures that defy expectations. It's like microwaving a single thread in a spider's web. The surrounding structure remains cool, but that one line crackles with frenetic energy. Then there's the dark matter factor. Simulations suggest filaments should trace the densest webs of dark matter, their gas illuminated only weakly by the ambient glow of the universe. But this filament's brilliance hints at something more. Perhaps dark matter isn't just a passive scaffold but an active participant, somehow transferring energy to ordinary matter in ways we've never observed. Imagine dark matter particles colliding and decaying within the filament, their invisible interactions sparking visible fireworks in the gas. The real puzzle, though, is the filament's uniformity. Unlike the chaotic, knotted structures seen elsewhere, this one gleams with eerie consistency along its entire length, as if something is regulating its glow. Some researchers propose a cosmic feedback loop. The filament might be funneling gas toward the cluster's center, fueling star formation and black hole activity, which in turn pumps energy back into the filament, creating a self-sustaining cycle of light. Yet the most tantalizing clue comes from its shape. Filaments are supposed to be slender, wispy things, but this one appears bloated in places, like a hose swollen with trapped pressure. Could we be seeing the aftermath of a galactic collision so violent it injected the filament with a surge of turbulent energy? Or is this a snapshot of the universe's infancy, a relic from a time when the cosmic web crackled with primordial energy? Whatever the answer, this radiant thread forces us to confront a humbling truth. The universe's largest structures might be hiding the deepest mysteries. And as we stare into its glow, we're left wondering, is this a fluke or a sign that the cosmic web is far more dynamic, far more alive than we ever imagined? Among the countless quirks of the Hercules Cluster, there's a region that behaves like a cosmic game of hide and seek, where galaxies and dark matter seem to actively avoid each other. This so-called anti-correlation zone flips conventional cosmology on its head, challenging one of our most fundamental assumptions, that dark matter and visible matter should cling together, bound by gravity's inexorable pull. Instead, here we find galaxies floating like islands in a sea of nothingness, their invisible scaffolding mysteriously absent. It's as if someone took a cosmic eraser to the dark matter map, leaving behind a void where the universe's hidden architecture should be. The first clue came from gravitational lensing, or rather, the lack of it. When astronomers mapped how the cluster warps background light, they expected to see the telltale distortions caused by dark matter's gravitational grip. But in this zone, the light passes through undisturbed, as if the space between galaxies is eerily weightless. Meanwhile, the galaxies themselves move too fast for the visible mass alone to hold them together, implying something must be anchoring them, just not where our models predict. One explanation points to a phenomenon called modified gravity, where the rules of Einstein's relativity break down on cosmic scales. Perhaps gravity weakens or twists in ways we can't yet measure, creating pockets where matter and its shadowy counterpart drift apart like oil and water. Yet the plot thickens when we consider detection biases. Could our instruments simply be missing the dark matter? Some theories suggest it might clump into ultra-dense, pinprick-sized halos too compact to lens light noticeably, like scattering grains of sand too fine to see individually. Others propose the dark matter here isn't missing at all. It's just too hot, meaning its particles move so fast they refuse to settle into the neat, galaxy-anchoring structures we expect. Imagine trying to catch smoke with your hands. The particles exist, but they slip through your fingers before they can coalesce. The most radical idea. This zone might be a fossil from the universe's infancy, a relic of a time before dark matter and galaxies learned to dance together. If density fluctuations in the early universe were just right, some regions could have ended up with too little dark matter to ever form the usual cosmic web. Like a patch of forest where the soil was too poor for trees to grow, these galaxies might be the stubborn survivors of a cosmic accident, thriving against the odds. Whatever the truth, the anti-correlation zone forces us to confront an unsettling possibility. That dark matter isn't just an invisible passenger in the cosmos, but an actor with its own whims, sometimes clinging to galaxies, sometimes ghosting them entirely. And if the rules of the universe can bend in one place, where else might they be hiding surprises? Flying through the Hercules Cluster at a speed that defies logic, one renegade star leaves a trail of cosmic breadcrumbs streaking away so fast it's effectively been exiled from its galactic home. Scientists call it the unbound hypervelocity star, a celestial projectile rocketing through space at over 1 million miles per hour, fast enough to cross the entire United States in less than 2 seconds. What could possibly give a star that kind of kick? The answer might rewrite our understanding of gravity's most extreme playgrounds. Most stars in a galaxy move like commuters in orderly traffic, following predictable orbits around the galactic center. But this one, it's more like a bullet fired from a cosmic gun, blasting through the void with enough velocity to escape the cluster's gravitational grip entirely. The leading theory points to a gravitational slingshot involving the cluster's supermassive black hole. Picture this: a binary star system wanders too close to the black hole's event horizon. One star gets captured, swirling into the abyss, while the other is flung outward like a stone from a sling, carrying all that pent-up orbital energy with it. It's the universe's version of a high-stakes betrayal, a stellar partner sacrificed for the other's escape. But here's where things get thorny. The trajectory doesn't quite align with any known black hole in the cluster, and the star's composition tells a story that doesn't fit neatly into the slingshot scenario. Its chemical makeup suggests it was born in a dwarf galaxy, one that might have been torn apart by the cluster's tidal forces billions of years ago. If true, this star could be a survivor of that ancient demolition, hurled into space when its home galaxy was shredded like paper in a storm. Then there's the dark horse theory, a supernova explosion gone rogue. If this star was once part of a tight binary system where its partner exploded catastrophically, the sudden loss of mass could have sent it careening away like a released rubber band. But hypervelocity stars launched this way are usually neutron stars, not the blazing, hydrogen-rich giant we're seeing here. Unless, of course, this star was just a bystander blasted forward by a shockwave from a nearby supernova, a cosmic shove from a dying neighbor. The most electrifying possibility: this star isn't just running, it's being chased. Some models suggest an intermediate mass black hole, invisible to current telescopes, could be lurking in the cluster's outskirts, its gravity flinging stars into the void like a celestial cannon. If proven, it would be the first evidence of such a black hole in Hercules, a hidden monster sculpting the cluster from the shadows. As this stellar fugitive barrels toward intergalactic space, it leaves behind more than just light. It's a roadmap to the violent, chaotic forces shaping the cosmos. Whether it's a black hole's castaway, a galactic collision's orphan, or something even stranger, one thing's certain: in the Hercules cluster, even the stars themselves can't always stick to the script. But perhaps no anomaly in the Hercules cluster defies logic quite like this, a ghostly bend in starlight with nothing to cause it. Astronomers call it the lensless mirage, a gravitational lensing effect so pronounced it should warp galaxies like a funhouse mirror, yet when they trace the distortion back to its source, there's nothing there. No supermassive black hole, no cluster of dim stars, just empty space curving light as if tugged by an invisible hand. Gravitational lensing isn't new. Einstein predicted it over a century ago. When massive objects warp space-time, they act like cosmic magnifying glasses, bending light from distant objects into arcs or rings, but lenses need mass. And this one's missing. The effect suggests something with the heft of a small galaxy lurking in the void, yet telescopes see no stars, no gas, not even the faint infrared glow of dust. It's as if gravity itself has gone rogue. One explanation cuts to the heart of modern astrophysics' biggest puzzle: dark matter. Could this be the signature of an enormous, diffuse clump of it, a loose halo stretching millions of light years, too thin to detect directly but massive enough to twist light? Simulations show dark matter isn't always neatly bundled around galaxies. Some might drift in vast, tendril-like structures, invisible except for the subtle way they tug on passing light. If true, this mirage could be our first clear snapshot of dark matter's skeleton, the universe's hidden scaffolding caught mid-act. Then there's the primordial black hole hypothesis, ancient relics from the universe's first moments. Unlike black holes born from dying stars, these could be any size, from microscopic to planet-smashing giants. A swarm of them, peppered across the cluster, might collectively warp light without leaving a detectable point of origin. Picture a cloud of pins scattered on a trampoline. Each dent is tiny, but together they create a landscape that bends anything rolling across it. But here's where the mystery deepens. The lensing pattern isn't smooth like a cloud. It's knotted as if something dense and compact sits at its core. That's led a handful of theorists to propose something far wilder: a single, intermediate mass black hole adrift between galaxies. These cosmic nomads are thought to form in chaotic galactic collisions, ejected from their homes to wander the void. If one exists here, it would be a needle in a haystack, dark, nearly impossible to spot unless it's actively feeding. Yet its gravity would still reach out, warping space-time like a stone dropped in water. The most unsettling possibility: we're seeing the wake of something that's already moved on. Imagine a black hole barreling through the cluster at incredible speed, its gravitational distortion lingering like the ripples behind a ship. By the time we detect the bent light, the culprit might be long gone, leaving behind only this eerie fingerprint. Whatever the truth, this mirage forces us to confront how much of the universe operates in the shadows. If empty space can bend light without a visible cause, what other invisible architects are shaping the cosmos, unseen and unsung? The Hercules Cluster seems determined to remind us sometimes the most profound discoveries aren't what we observe, but what we can't. And the real question isn't just what's bending the light, it's how many more cosmic conjurers are hiding in plain sight. Among the sea of stars in the Hercules Cluster, one ancient gathering stands out not for what it contains, but for what it lacks. The metal-poor paradox is a star cluster so devoid of heavy elements that its existence challenges our timeline of cosmic evolution. These stars shouldn't be here, not in a region this developed, not surrounded by galaxies that have been churning out metals for billions of years. It's like finding a prehistoric cave painting untouched by time in the middle of a bustling modern city. The mystery starts with the basics. In astronomy, metals aren't just iron or gold, they're any element heavier than hydrogen and helium. These heavier atoms are forged in the hearts of stars and scattered across the cosmos by supernova, seeding future generations of stars with richer chemistry. Over time, stars in dense clusters like Hercules should have absorbed these metals, becoming at least somewhat seasoned. But this cluster, its stars are nearly pristine, their atmospheres almost chemically blank, as if they formed from gas untouched by stellar explosions. One explanation is as mind-bending as the paradox itself. These stars might be true relics from the universe's infancy, a surviving pocket of the first ever generation of stars. Astronomers call these hypothetical pioneers population Roman 3 stars massive, short-lived giants born from pure hydrogen and helium, whose deaths would have kick-started the chemical enrichment of the cosmos. If this cluster is their descendant, it could mean we're looking at a fossilized fragment of the earliest universe, preserved by some fluke of orbital dynamics. The problem: no one's ever definitively found a population Roman 3 star, let alone an entire cluster of their offspring. Then there's the contamination theory. What if this cluster wasn't always metal-poor, but had its chemistry artificially diluted? Imagine a dwarf galaxy, rich in primordial gas, colliding with the Hercules Cluster and dumping its unevolved contents into this stellar family. The fresh hydrogen could have mixed with the cluster's existing stars, lowering their overall metallicity like watering down soup. Supporting this idea are faint streams of gas nearby, possible debris from such a collision. Yet even this elegant solution has cracks. The star's motions don't quite match the expected paths of a recent merger, and their ages vary wildly, suggesting a more complex history. The plot thickens when we consider dark matter's role. Some models suggest ancient star clusters could have formed in the dense cores of dark matter halos, their chemistry protected from pollution by the halo's gravitational isolation. If this cluster is nestled inside one of these cosmic bubbles, it might have avoided the chemical pollution that swept through the rest of the universe. But the most tantalizing clue lies in the stars themselves. A handful show strange chemical fingerprints, trace amounts of elements like carbon and oxygen, but none of the heavier metals like iron. This selective enrichment hints at a rare type of supernova, one that only produces lighter elements, possibly from the very first stars. If confirmed, these traces could be the smoking gun linking this cluster to the dawn of time. Whether it's a cosmic time capsule, a contaminated oddity, or something even stranger, this metal-poor enigma forces us to reconsider how galaxies evolve and how much of the ancient universe might still be hiding in plain sight. After all, if one cluster slipped through the cracks, how many others are out there, quietly defying the rules? Deep in the Hercules Cluster, astronomers have stumbled upon a cosmic blind spot, an eerie patch of space where X-ray light simply vanishes, as if something invisible were standing in its way. This X-ray shadow mystery defies simple explanations, presenting astronomers with a cosmic riddle wrapped in the absence of light. Normally, X-rays flood galaxy clusters, emitted by superheated gas swirling between galaxies. But here, something is casting a shadow, absorbing this high-energy radiation without leaving a visible trace. The culprit, that's where things get truly fascinating. One leading suspect is a colossal cloud of ultra-cold gas. Picture a fog so dense and frigid it acts like an interstellar sponge, soaking up X-rays before they can reach our telescopes. Such clouds, if they exist, would need to be staggeringly massive, far larger than any observed before, and chillingly cold, just a few degrees above absolute zero. The problem: gas this cold should collapse under its own gravity, forming stars or at least glowing faintly in other wavelengths. Yet this shadow gives up no such clues, remaining stubbornly dark across the electromagnetic spectrum. Then there's the exotic matter hypothesis. Could this shadow be the signature of something entirely new, a form of dark matter that interacts with X-rays in ways we've never imagined? Some theories propose hypothetical particles like actions or sterile neutrinos, which might absorb or scatter high-energy light without emitting anything detectable in return. It's like searching for a thief who leaves no fingerprints, no footprints, only the missing items as proof they were ever there. But the plot thickens when we consider the shadow's shape. Unlike the blurry edges of a gas cloud, this void has surprisingly sharp boundaries, as if whatever's blocking the X-rays is structured, almost deliberate. That's led a handful of researchers to toy with an even wilder idea: primordial black holes. Not the star-sized ones we know, but ancient grapefruit-sized relics from the Big Bang, clumped together in a vast, invisible swarm. Their combined gravity could bend X-rays away, creating the illusion of absorption while hiding in plain sight. The most tantalizing clue comes from the shadow's motion. Over years of observations, it seems to drift slowly across the cluster, as if whatever's casting it is moving independently of the galaxies around it. If confirmed, this could rule out static structures like gas clouds, pointing instead to something dynamic, a wandering absorber with a mind of its own. Whether it's a ghostly gas cloud, a new form of matter, or a swarm of black holes from the dawn of time, this X-ray shadow forces us to confront a humbling truth. Even the emptiest-looking patches of space might be hiding secrets we're only beginning to uncover. And in the Hercules Cluster, where every anomaly seems to rewrite the rules, the greatest mysteries might not lie in what we see, but in what we don't. Among the countless galaxies swirling through the Hercules Cluster, astronomers have spotted something that defies the odds: not just one or two, but dozens of galaxies spinning in perfect synchrony, their rotations locked together like gears in a cosmic clock. This isn't just unusual, it's statistically near impossible. These galaxies are separated by millions of light years, far too distant for gravity or any known force to link their motions. Yet their spins align with eerie precision, as if an invisible hand set them in motion with a single, deliberate twist. The mystery starts with tidal locking, a phenomenon we're familiar with in our own solar system. Our moon, for example, always shows the same face to Earth because gravity has synchronized its rotation with its orbit. But for galaxies, the scales are staggering. Locking even one pair would require forces beyond anything we've observed, let alone an entire chorus of them moving in harmony. The energy needed to orchestrate this dance would dwarf the output of supermassive black holes, and the time required stretches longer than the universe itself has existed. So how could nature pull off such a feat? One radical theory points to dark flow, a controversial concept suggesting vast streams of matter, or something even stranger, might be tugging on galaxies from beyond the observable universe. Imagine a cosmic river flowing through space, its current subtly nudging galaxies into alignment over eons. While mainstream cosmology remains skeptical, the synchronized spins in Hercules present one of the strongest cases yet for this fringe idea. Then there's the cluster's violent history. Galactic collisions are common here, and some researchers propose these synchronized galaxies might be survivors of a single, ancient mega-merger. Picture two colossal galaxies smashing together billions of years ago, their violent encounter sending shockwaves through the surrounding gas. Those waves could have triggered star formation in neighboring galaxies, imprinting them with matching spins like ripples synchronizing floating leaves. But the most tantalizing clue lies in dark matter. Simulations show dark matter halos, the invisible cocoons surrounding galaxies, can remember the direction of primordial cosmic spins. If these halos formed in a region of the early universe with a preferred rotation, their descendant galaxies might inherit that spin, creating the illusion of synchronization across vast distances. It's as if the universe planted a hidden code in its infancy, one we're only now deciphering. Whether it's dark flow, collision echoes, or dark matter's ghostly influence, these synchronized galaxies challenge our deepest assumptions about how the cosmos organizes itself. And if galaxies can move in unison without any visible tether, what other invisible threads might be weaving the universe together behind the scenes? And then there's the signal, the one that made astrophysicists do a double take. Buried in the radio chatter of the Hercules Cluster is a transmission so peculiar, it briefly sent the scientific community into a frenzy. Dubbed the Hercules signal, this repeating burst of radio waves pulses with an almost rhythmic precision, its structure just a little too orderly to dismiss as random cosmic noise. At first glance, it ticks all the boxes we'd associate with an artificial broadcast narrow frequency range, strange spectral patterns, and a cadence that feels almost intentional. The initial discovery sparked a flurry of speculation. Could this be a beacon, a cosmic SOS? The truth, as always, is likely far more mundane but no less fascinating. The signal's most probable explanation lies in natural astrophysical processes, perhaps a never-before-seen interaction between a pulsar and a dense cloud of interstellar plasma. Picture a lighthouse beam sweeping through fog, its light scattering and distorting in unpredictable ways. Now imagine that lighthouse is a spinning neutron star, and the fog is a turbulent sea of charged particles. The result, a signal that mimics intelligence without any actual mind behind it. Yet the sheer improbability of such a perfect mimicry keeps the door cracked open for wilder possibilities. What if we're witnessing the decay of some exotic quantum structure, a cosmic defect left over from the early universe vibrating like a plucked string? Or the remnants of a hyper-advanced civilization's long-dead technology, its automated systems still pinging the void long after its builders vanished? Even the most hardened skeptics admit the signal's structure is unusual enough to warrant a second look. Here's where the plot thickens: the signal's location. It isn't coming from a galaxy's busy core or a star-forming region, but from the relative emptiness between galaxies, a cosmic no-man's land where few natural radio sources dwell. That isolation makes it harder to pin down a plausible natural origin. If it were a pulsar, we'd expect to detect X-rays or gamma rays accompanying the radio pulses. Instead, the Hercules signal stands alone, a solitary enigma in a sea of static. Then there's the elephant in the room, the wow signal. astronomers can't help but draw parallels to that infamous 1977 blip, another radio burst that seemed tailor-made to spark debates about extraterrestrial intelligence. But unlike WOW, which lasted mere seconds and never repeated, the Hercules signal has been detected multiple times, always with the same peculiar fingerprint. That consistency rules out many one-off cosmic accidents, forcing us to confront the unsettling question: if this isn't natural, what could possibly be broadcasting with such persistence, and why? For now, the scientific consensus leans toward caution. Extraordinary claims require extraordinary evidence, and a natural explanation, however complex, is still more plausible than alien megastructures. But the Hercules signal lingers in the back of every researcher's mind, a quiet reminder that the universe has a flair for the dramatic. Whether it's a cosmic coincidence or something more, one thing's certain: in a cluster already overflowing with mysteries, this signal might just be the most tantalizing clue of all. The Hercules Void isn't just a cosmic oddity, it's a throbbing headache for modern cosmology. Recent supercomputer simulations designed to recreate the universe's large-scale structure under the trusted lambda-cold dark matter model have hit a wall when it comes to explaining this yawning chasm of nothingness. According to our best theories, matter should be distributed relatively evenly across the cosmos, with small fluctuations from the Big Bang eventually snowballing into the web of galaxies and voids we see today. But the Hercules Void is different. It's not just a gap, it's a deviation, a statistical glitch so extreme it makes even the most sophisticated simulations stutter. Take the Millennium simulation, one of the most ambitious attempts to model cosmic evolution. When scientists fed it the known parameters of the universe, dark energy's acceleration, dark matter's gravitational glue, it spat out a cosmos studded with voids, yes, but none approaching the sheer scale and emptiness of the Hercules anomaly. The numbers just don't add up. For a void this vast to form naturally, you'd need primordial density fluctuations far stronger than the ones we've mapped in the cosmic microwave background. It's like rolling 1,000 dice and getting 1,000 ones, technically possible, but so unlikely it hints at a flaw in the game itself. Then there's the timing problem. Voids this size should take longer to form than the current age of the universe allows. Think of it like a sinkhole developing in loose soil. Gravity pulls matter slowly toward denser regions, leaving behind emptier pockets over eons. But the Hercules Void is more like a sinkhole that appeared overnight, defying the gradual pace of cosmic expansion. Some researchers have tweaked dark energy's behavior in simulations, cranking up its repulsive force to see if accelerated expansion could carve out such a void faster. The results mixed. While stronger dark energy does create larger voids, they're still not as empty as Hercules. There's too much leftover gas, too many straggler galaxies, fine cosmic dust where there should be a vacuum. The real curveball comes from alternative theories. One fringe idea suggests the void might be evidence of a collision between our universe and another bubble universe in the multiverse. A cosmic bruise where two realities briefly brushed against each other, draining matter from the contact point. Others propose modifications to gravity itself, like modified Newtonian dynamics, which tweaks the rules at large scales to explain anomalies without invoking dark matter. But even these radical fixes struggle to account for the void's pristine hollowness. If modified gravity or multiverse clashes were the culprit, we'd expect to see other side effects. Twisted galaxy shapes, skewed light-bending patterns, none of which appear in Hercules. Perhaps the most unsettling implication is what the void doesn't show. In most voids, even the emptiest patches contain faint traces of ionized gas or drifting dark matter. But Hercules is eerily clean, as if something actively scoured it bare. That's led to speculative but tantalizing ideas like primordial black holes acting as cosmic vacuum cleaners, or dark matter decaying into invisible particles over billions of years, leaving behind a ghostly hollow. Whatever the answer, the Hercules Void isn't just a curiosity. It's a flashing neon sign pointing to the cracks in our understanding. Every failed simulation, every adjusted parameter whispers the same uncomfortable truth. The universe might be playing by rules we haven't discovered yet. And until we solve this cosmic missing piece puzzle, even our most trusted models will feel like incomplete sketches of a far stranger reality. Those mysterious bursts of cosmic static known as fast radio bursts aren't just celestial oddities. They might be the universe's most powerful diagnostic tools. Take the Hercules repeater, that erratic signal flickering from the cluster's depths. While its origins remain debated, astronomers are realizing these fleeting flashes hold immense value far beyond their source. Each burst carves a path through the cosmos, and along the way it collects fingerprints, subtle clues about the invisible matter it traverses. Think of a fast radio burst as a lighthouse beam piercing fog. As the light travels, water droplets scatter and absorb certain wavelengths, leaving telltale gaps in the signal. FRBs behave similarly, but instead of water, they encounter the diffuse plasma floating between galaxies. This ionized gas leaves its own imprint, subtly distorting the burst shape and arrival time. By analyzing these distortions, scientists can map the distribution of matter across vast intergalactic distances, matter too faint to see directly. It's like cosmic tomography, using fleeting radio flashes to X-ray the universe's hidden scaffolding. But there's a catch. The Hercules repeater's inconsistent behavior complicates this elegant picture. Most FRBs are one-offs, but repeaters like this one offer multiple data points, theoretically making them ideal for mapping. Yet the repeater's signals vary wildly in intensity and spacing, as if something between us and the source is intermittently smudging the lens. Some pulses arrive crisp and clear, others are stretched and warped, suggesting turbulent pockets of plasma or magnetized gas distorting their journey. Untangling these distortions becomes a game of astronomical forensics, separating the burst's original features from the interference layered atop it. The biggest hurdle lies in the dispersion measure, the delay between high and low-frequency radio waves caused by traversing ionized gas. Normally, this delay helps estimate how much matter a burst has passed through. But repeating FRBs throw a wrench in the works. If multiple bursts from the same source show different dispersion measures, it implies the path itself is changing. Maybe floating plasma clouds drift into the line of sight, or the burst's local environment evolves between emissions. Either way, these variations turn what should be a straightforward calculation into a three-dimensional puzzle with moving pieces. Then there's the Faraday rotation effect. As FRBs travel through magnetized regions, their polarization twists like light passing through polarized sunglasses. The Hercules repeater's polarization shifts unpredictably, hinting at complex magnetic fields threading the cluster, fields that could trace otherwise invisible structures like galactic winds or dark matter filaments. The challenge: each twist encodes information about multiple magnetic regions along the path, stacked like layers in an onion. Disentangling them requires comparing bursts that have taken slightly different routes, a task made maddeningly difficult by the repeater's refusal to follow a predictable schedule. Despite these headaches, the potential rewards are staggering. If we can decode these patterns, FRBs might reveal not just the location of hidden matter, but its temperature, density, and even its motion. Imagine tracking the swirling currents of intergalactic gas in real time, or spotting the faint wakes left by dark matter's gravitational tides. The Hercules repeater, for all its capriciousness, could be the key to turning these flashes from cosmic curiosities into precision instruments, proof that sometimes the universe's most frustrating signals hold the deepest secrets. From gaping voids where galaxies refuse to form, to rogue stars catapulting through space fast enough to escape gravity's grip, the Hercules Cluster isn't just a collection of cosmic oddities. It's a living laboratory where the universe stress tests our understanding of physics itself. Think about it. We've encountered phantom spiral arms materializing from nowhere, black holes locked in gravitational standoffs that defy merger predictions, and entire galaxies vanishing without a trace. Each of these 25 phenomena isn't just a puzzle. They're keys rattling the foundations of cosmology, daring us to rethink dark matter, question gravity's rules, and even reconsider what lurks in the so-called empty stretches of space. Take the synchronized galaxies spinning in unison like a celestial ballet despite being light years apart, or the Hercules signal, that eerie radio transmission pulsing from the void with almost deliberate rhythm. These aren't just curiosities, they're signposts pointing toward forces we've yet to name. And let's not forget the diamond world orbiting a pulsar, or the X-ray shadow cast by, well, nothing we can detect. Every observation peels back another layer, revealing how much we still don't know about the universe's blueprint. What makes the Hercules Cluster so extraordinary isn't just the sheer volume of its mysteries, it's how they intertwine. The same void that challenges our models of cosmic expansion might hold clues about dark energy. The Flickering Quasar's tantrums could rewrite black hole physics. Even the minor anomalies, like the backward streaming gas cloud, whisper about magnetic fields and dark matter in ways textbooks never predicted. Together, they paint a picture of a cosmos far more dynamic, far more alive with possibility than we ever imagined. So here's the real question. What's your favorite Hercules enigma? The star cluster with mismatched ages, the lensing effect with no lens? Drop your pick in the comments, because the beauty of these mysteries isn't just in solving them, but in the conversations they spark. After all, the universe's greatest gift is its endless capacity to surprise us. And as long as places like the Hercules Cluster keep serving up cosmic head-scratchers, we'll keep looking up, wondering, and pushing the boundaries of what we think we know. Stay curious. The next big discovery might be hiding in plain sight, waiting for someone to connect the dots.